So let's start today's discussion. I guess not much of students today. So today, in this week, Professor Ram has taught the root-locus method. So before diving into this question will solve, this single question will solve all the kind of root-locus problems, and this will help you solving half of the more than half. I guess 15 questions are there in the assignment, and more than half, like 7 8 questions, are directly like very much related to this question only. So you get this, you will able to solve half of the question. But before that, I want to explain what is root locus and why do we need this. One second, I'll just close everything. Am I audible? Can somebody just confirm? Otherwise, okay, okay. Thank you, thank you. Okay. So, what is root locus? So, the name itself is self-explanatory. Like, it's the locus. Like in your 12th, while preparing for your 12th, like the JE exam, you might have gone through the locus, parabola, hyperbola, circle, straight line, those kind of locus. So, it's the locus of the roots of the characteristics equation with some parameter, with the variation of some parameter, variation of some parameter. So this is just a definition. Let's try to understand what the definition says. Like in a classical control system, if this is my system, I can write it as G of S, which has some numerator and denominator. I want some quick answers. The A of S is equal to 0. The corresponding S will be called as zeros or the poles. Can somebody just say quickly? Like if I equate A of S is equal to 0 and solve for S, for what values of S, A of S is 0, then that is called the zeros of the system or the pole of the system. Uh, three guys, like there is nothing to fear. Like if you don't know or if you say wrong, there are two options: either they will be poles or they will be zeros. So what do you think? Very simple question. You can type in the chat box also. Okay. So for whatever values, A of S is equal to, for S, A of S is 0. It's called the zeros of the system. And for B of S is equal to 0. If we equate B of S, the denominator part is equal to 0, then the solutions will be called the poles of the system. Okay, simple. So if I want to, and this is my reference signal. Okay, this is my reference signal, and this is my controller. If you haven't watched the controller and known why controller is required and how it's useful, I will highly recommend to go through the lectures or my previous on like week 5 live session. I have given few examples why controller is important and how it's useful for stability. Okay, so this is controller and this is the output, and this is a negative feedback system. Okay, let us assume my controller is simply a P controller or proportional controller. So this will be having K, only K. Then my this system, this will be open loop transfer function G star of S, which is called open loop transfer function. So if I open loop transfer function G star of S is equal to K A of S divided by B of S, can somebody say what is my closed loop transfer function? If you have come this far of the course, this might be very straightforward. Can somebody just say or type? Mm, I guess there is absolute silence. Okay. I will say the answer. So this would be K A of S divided by B of S whole divided by, because it's a negative feedback system, that's why 1 plus K A of S divided by B of S. Okay. So ultimately this will be K A of S whole divided by 1 plus, sorry, this will be B of S plus K A of S. Okay. So for my open loop transfer function, and what is the condition for stability? My stability condition, if all the poles lie on the left hand side, lie on the left half of the S plane. Okay. So if you don't know why these things are happening, or the lectures series you can watch, or the discussion session, live discussion session for the past 5 weeks, I have explained these things. Why for stability, all the poles need to be on the left hand side. You can watch them. So my concern is, I know my open loop, this A of S and B of S, but this B of S plus Ka of S, how the poles of this equation, that that is decided by the root locus method. Okay, so there are particular some steps for drawing the root locus you might be knowing. So I would like some participation. If you will participate, that will be very beneficial. So let's write down step one. What's the step one for any root locus design? So let's any root locus design. Let's first take the transfer function g of s is equal to, I have already mentioned this, a of s by b of s, simple. And assume let's assume there are excuse me, there are m zeros and n poles. Okay, that means s plus z1, s plus z2 up to s plus zn. M, because there are m zeros, divided by s plus p1, s plus p2 up to s plus pn. There are you can see there are m number of zeros and n number of poles. Okay, and typically n is greater than m. Okay, for a proper transfer function. Okay, so what is the first step? First step, okay, just write step one. What you need to do, you need to locate the open loop poles. Okay, so where in this S plane, this is the S plane, this is the real, and this is the imaginary. So first locate the open loop poles. That means this is P1, this is P2, this is P3, this is P4. This kind of locate you need to locate. Okay, and you must know root locus starts at poles and ends at zeros. This is open loop and this is open loop of zeros. So that that means that those branches which do not end on the open loop zeros, they will tend to infinite. They will find, like, it's like finding their own partner. Okay, so for m number of poles, the root locus will start and they will find their own partner. But for n minus m, because n is greater than m, they don't find their partner, uh, because the zeros are less. So they will search till infinite, like, where is my partner? Okay. Step two. The step two is kind of, just a second. Okay. Then locate the poles on the real axis. Okay. That kind of. Can somebody just reconfirm whether they know these steps or not? Otherwise, I will directly go to the question. Any of you? Uh, they know? Do you know these steps? So that I'll directly go to the question and we'll solve that. Shubhangi or Sundari? Anybody? You know these steps, right? So I can go directly to the question, or I will explain a little bit on the steps. ओके, मतलब थोड़ा बताना है इस स्टेप्स के बारे में, या फिर आप लोगों को पता है तो मैं डायरेक्टली गो टू द क्वेश्चन? ओके, ठीक है, ठीक है, देन आई विल लिटिल बिट एक्सप्लेन. ओके, रियल एक्सेस. देन स्टेप 3, इट्स डिटरमाइन centroid and asymptotes. Okay, then step 4 is finding breakaway points. Okay, so let's come back to the question. Okay, so the question says, uh, let let the open loop transfer function of a negative feedback controlled loop system is this one, and k is a non-negative real value. So this is very important. K is greater than or equal to 0, because it says k is a non-negative real value. Okay, then the first question, the first step, what I had mentioned, we need to find the poles and zeros. Okay, so I have mentioned, if it's a of s by b of s kind of equation, equate a of s is equal to 0, you will find the zeros, and equate the b of s is equal to 0, you will find the poles. So let's find out. So s plus 1 is equal to 0, that means s is equal to minus 1. This is a 0, and we'll equate s cube plus 2s square plus 2s is equal to 0. That means s into s square plus 2s plus 2 is equal to 0. That means s is equal to 0 and s is equal to minus 1 plus or minus j. If you solve this, you will get this question, this coefficient. So these three are the poles. So if I want to draw, okay, if I want to draw, maybe just a second. Okay. So if I want to draw it, so my pole is at 0 and -1 plus or minus -1, this is -1, this is j, and this is -j. So my poles will be here, and my 0, where is my 0? 0 is at -0. So this is my 0. Okay. So the first question says, how many branches does the root locus have and where would they terminate? I have already mentioned the number of poles, whatever the number of poles, that is the number of branch, because for k is equal to 0, the branches will start at the poles. So the poles, the number of pole is equal to the number of branches. So how many branches? It has number branches equal to 3. And where they would terminate? They will terminate at 1, because it has 1 0. So one branch at 0 and the other at other 2 at infinite, because the system has only one 0. So out of the 3 poles, 1 pole branch will be terminated at the 1 0, and the rest 2 will be terminated at infinite. So okay, this question is solved. Next question is, the complex conjugate open loop poles are located at. The complex conjugate open loop pole, this is simple, 1 plus or minus j. So one is at 1 plus j and another is 1 minus j. Very simple question. This is done. Okay. The third question is, the region of real axis that lies on the root locus. Okay. Now come back to the diagram. So the real axis, this is the real axis. I should mention this. This is the real axis and this is the imaginary axis of the S plane. Okay. So let's divide the region of real axis into 3. One is this, one is this, and one is this. So let's term 1, this is 2, let's give another color. This is 1, this is 2, and this is 3. This is at -1 and this is 0. So according to our second step, the number of poles and zeros, the sum of number of poles and zeros on the right hand side must be odd. So when I take any point in region 1, any point in this region, so for any point I have 2, this 0 and this pole, I have 2 number of poles and zeros on its right hand side. That's why this region is not considered. This is not a part of the root locus. Okay. When I come back to this one, the second part of the real axis here. Now when I choose any point in between, I have only one pole on the right hand. Anywhere I choose any point I take, I have only one pole at 0. So that's why this is part of the root locus. And what about this part? In the third as well, there is no poles towards the right. So 0, it's not odd number. That's why the region on the real axis that lies on the root locus is -1, 0. Okay. Then this question is solved. Next, come back to the next question, D. The number of asymptotes on the root locus plot. Okay. The number of asymptotes, the formula is number of open loop poles, number of open loop poles minus number of open loop zeros. That is m, here n minus m. So it will be, I have 3 open loop poles, 3 minus 2, okay, 3 minus 2 minus 1, because 1 open loop 0, so it will be 2. Straightforward, fairly. Okay. The angle in degree, the next question is the angle in degree made by the asymptotes with the positive real axis. Okay. So what is the angle made by the asymptotes? This is 180. The formula is minus 180 degree into plus or minus 180 degree 2k plus 1. Okay. This is the divided by n minus m, where n is the number of poles and m is the number of zeros. This is asymptotes. Asymptote degree. Okay. So what is our plus or minus 180 into 2k plus 1 whole divided by 3 minus 1. That means plus or minus 90 degree. Okay. That means our asymptotes will have the angle with positive real axis, it's 90 degree, and negative 90 degree is 270 degrees. Okay, simple. Next question is the point of intersection of the asymptotes. The point of intersection of the asymptotes is also known as the centroid of the root locus. So it has the general formula: the sum of poles, this is the centroid, minus the sum of zeros whole divided by n minus m. That means this, what is the sum of here in our equation? What is the sum of poles? The sum of poles is 1 is 0 plus 1 1 minus j minus 1 plus j. This is the sum of poles minus sum of zeros. What is the my zero? My zero is at minus 1. So by n minus n. So this will come 3 minus 1. So this will come at 1 by 2. You can minus 1 by 2. You can verify this. So this question will be 0.5. Okay. What are the breakaway and break-in points? This is a very important question, like where I want all of your attention. So what I started with, let me take another paper. Okay, so let's take what I started with my system equation as A of s whole divided by B of s. Okay, and when I multiplied the k amount on the open loop transfer function, the g star of s is equal to k A of s whole divided by B of s. So the possible break-in or breakaway points, the equation is b dash of s minus into A of s minus A dash of s B of s is equal to 0. So dash means the derivative, first derivative. Okay. So here in our equation, what is the system? The system is like A of S by B of S. The equation is S plus 1 whole divided by S into S square plus, sorry, I will directly write S cube plus S cube plus 2S, 2S square plus 2S. Okay, that means my A of S is S plus 1 and B of S is equal to S cube plus 2S square plus 2S. So just calculate what is my A dash of S. Uh, Balkiran, if you are there, can you tell what is the A dash of S? Hello, am I audible? Hello, can somebody just confirm? Hello. Okay, I think there is some internet issue at my end. Continue the question. So A dash of S will be 1, simple, because A of S with respect to S. So what is my B dash of S? 3S square plus 4S plus 2. Okay, that means B dash of S into A of S minus A dash of S B of S is equal to 0. You will get 3S square plus 4S plus 2 into A of S, it is S plus 1 minus 1 into S cube plus 2S square plus 2S is equal to 0. So if you solve this, you will like end up with the expression 2S cube plus 5S square plus 4S plus 2 is equal to 0. So if you try to plot this, you will get S is equal to minus 1.65 and S1, S2, S3, they will come as minus 0.42 plus or minus J 0.6. Okay, yes, I'll write it again. S2 will be 0 minus 0.42 plus or minus J 0.65. Balkan, can you confirm where I am audible or not? You can type it in the chat box or you can unmute yourself and say whether I'm audible. Okay, thank you. So, you joined a little bit late. So, we have discussed one problem up to this map. Okay. So, okay, I am not done yet. So, these are the S1, S2, and S3. Yeah, Balkaran, just tell me whether you know the root locus method of plotting the root locus steps or not, so that I'll be briefing you about the steps or like the question again. It's a very fairly straightforward question. So, do you know? Have you gone through the lectures? And you know how to draw the root locus? Okay. Okay. So these three. Okay. Sir, can you please briefly explain? Okay. I'll briefly explain. Or otherwise, you can watch the video a little on YouTube. Okay. I will explain it again also, these questions. So, uh, these are the probable, but I have explained this part, this part, and this part are not cannot be part of the root locus method. So when the point s1 is equal to minus 1.65 comes, it will lie somewhere around this place, which is not part of the root locus. So it cannot be a breakaway point. So this point is not a part, cannot be a breakaway or break-in point. Similarly, you can check for this minus 0.42 plus or minus, this will also not satisfy the root locus properties. The two basic root locus properties, what are the two basic root locus properties? One is the magnitude criteria and another is the angle criteria. Do you remember, Balkiran, what is the magnitude criteria and angle criteria? The magnitude criteria says my open loop transfer function, the g of s, h of s magnitude should be 1 and the angle of g of s, h of s should be 180 degree, minus 180 degree. Very good, very good. Okay, so you can verify this two point also doesn't satisfy that. That's why this root locus, when we plot the root locus for this, it doesn't have any breakaway or break-in point. Okay, doesn't have. Okay, I'll write it in the red. Does not have. Okay, okay. Now comes give the range of k for which the closed loop system will be stable. Okay, so now what is my equation? My open loop transfer function is k s plus 1 whole divided by s cube plus 2s square plus 2s. So I can directly write my closed loop transfer function. This will be k s of this uh, s cube plus 2s square plus 2s plus ks plus k. Do you get it? How I got this equation, the closed loop transfer function? Simple. G of s whole divided by 1 plus g of s. Okay, because the h of s is 1 here. So the closed loop transfer function is this. Then what says for the closed loop transfer function to be stable, all my poles of the closed loop transfer function must be on the left hand side of the plane. That's I have been repeating from the class 2, the second live session. So my condition is all the poles must lie on the left hand side. Okay. To get that, we already know the Routh array, which we used in the last class. So let's draw the Routh array and find out what is the condition. Just looking at it, can you, Balkiran, say what is the condition on S? Sorry, K. Okay, that's a shortcut. That don't rely on that. So this is 1, and this will be K plus 2, and here S square it's K. Sorry, it's 2 and K. Okay, so this will come as 2 into K, 2K plus 4 minus K whole divided by 2. This doesn't have anything, and here you will get K. You know, do you remember how to draw, like how to get the Routh array? This calculation, you remember, right, Marker? So if we simplify it, it will be K plus 4 whole divided by 2. Okay. So my condition says if there is no sign change on the first column, this is my first column. So if there is no sign change, then I can assure all my poles are on the left hand side. So for no sign change, my K should be greater than 0 and my other condition is k should be greater than -4, so that all the equations will be positive. So that means my condition should be k is greater than 0. Is it clear? So this condition is k should be greater than 0. Simple. Now let's come back to the second problem which I have considered for this class. K, okay, k should be greater than -2, you are saying. Okay, let's come back here. Okay, here you need to be little bit careful because it's k plus 4 divided by 2 should be greater than 0. That means k should be greater than -4. Okay, but it doesn't matter because when the conditions are uh, k should be greater than -4, like this path, and k is greater than 0. Okay, this path, then you have to take the intersection, not the union. Okay. Okay, next come to the last question of the day. The open loop transfer function of a unity negative feedback closed loop system is this. For a closed loop transfer function, for the closed loop system, does s -1, s is equal to -1 satisfy the magnitude and angle condition? So I have just said the uh, magnet like uh, what magnitude and angle condition just stated. Do you remember? Magnitude should be g of s, h of s should be 1, and the angle you have mentioned that g of s, h of s should be -180. Okay, so let's try. Here you have say we unity negative feedback. That's why we can directly say h of s magnitude is 1. That means g of s, h of s should mod of s plus 1 divided by s square plus 4s at s is equal to -1. Can you calculate it quickly? It's directly very straightforward. It's very simple. Can you calculate and tell me what is the magnitude here? If you put s is equal to -1, the magnitude will come at 0. Very good. You have calculated 0. That means the magnitude criteria is not satisfied. So the magnitude criteria is not satisfied. And what about the angle criteria, angle condition? For the angle condition, can you check again whether the angle condition is satisfied? The angle for s plus 1 divided by s square plus 4s at s is equal to -1. Can you check and tell me? It will come at 0 degree again, 0 or 360 degree. Okay, you can verify this because straight directly the numerator will be 0, and that's why, and the denominator will also be 0. Okay, no, some constant value. The numerator will be constant value. So this will, that means the angle condition is also not being satisfied. Is it clear, Balgran? Okay. So these are the questions. This kind of questions you will find in the assignment for this week. So I will just brief you about the first assignment question here. So the equation is given for this, and it was asked how many branches and where it will terminate. Very basic question. What are the open loop poles? What and the region of the real axis? Very straightforward, simple questions. This kind of questions you will find in the assignment. So you can watch this video later. And I want to announce that in the next week I'll give some MATLAB demonstration. So that's gonna be very useful, and I think that will be very beneficial for future also, for your future. Like you will be learning a little bit of MATLAB. Whatever you have done in hand, we'll be implementing in MATLAB. So that will be very beneficial, I feel. So if you are interested, you can join. Okay. Anything else, Balkiran, you want to ask? Because this week's lecture, I think I'm done with the content. Uh, okay. So thank you. Have a great week ahead. Okay, and please do join the next week. I will be demonstrating MATLAB. Thank you.